Hello everyone and welcome to another blockchain video. In today's video we're gonna talk about Solidity, the main language for writing smart contracts on the Ethereum blockchain. As you can see here on the documentation, it's an object-oriented high-level language. It's very similar to JavaScript, influenced by C++, Python and JavaScript, and it's designed to target the Ethereum virtual machine. You can go ahead here in the documentation and read more advanced stuff about it, I recommend it, but in today's video we're gonna go and dive in and write some smart contract. In this video you don't have to download anything, you just go to remix.ethereum.org and here it is where we're gonna write the contracts, compile, deploy them and test them. So let's begin. Let's create a new file. Let's call this my contract. That's Solid's the extension for Solidity. So let's see. Okay, so the first thing we have to write is the Solidity number. Well, we do this with pragma Solidity and the number. Let's say 040. So we start implementing our contract now. Let's call this my contract. Okay, so let's start with a variable in integer called votes and a function called add vote. Okay, we'll just do votes equal votes plus 1. Okay, and we'll make this 0. Fair enough. Let's deploy now and see what happened. We'll use the JavaScript virtual machine and we can click deploy. Okay, so now our contract is on the blockchain. But let's add this here so we can actually see the votes. Okay, so if you can see here, now we have 0 votes. Let's add a vote. We can see here that the transaction happened successfully, and if we click on votes now, we have 1 vote. Click again here, 2 votes. Okay, so now let's talk a little bit about visibility. So in Solidity we have 4 types. We have public, we have private, we have internal, and we have external. So what's the difference between those? Well, public means it is accessible from anywhere, from outside the blockchain, from inside the blockchain, from this contract, from another contract, from everywhere. Private, it means that it is only accessible from within this contract. Internal, it means that it's accessible from this contract and all contracts derived from it. And external, it means it's only accessible from outside this contract. Now let's clarify something. There's a little difference between visibility for functions and visibility for variables. Default a function is public, but the default for state variables is external. Okay. Okay, so now let's play a little bit with those 4 keywords and see how they actually work. So this is default public, so let's say public. Okay, so okay, no, not here, here. Okay, so this is public, but let's make this private. So let's compile, let's deploy, and we don't have it here. okay, we only have add vote. So let's make another one, and let's say function add vote 3. Okay, and let's make this one external. Okay, so let's add 3. Okay, so let's compile, let's deploy, and we have it here. Okay, so let's see how if it works. Okay, nice, we have 4 votes. Okay, so this is external. Okay, remember, let's try and call it from here. Let's type add votes 3. Okay, so we see we have an error, undeclared identifier. So if we are going to make this public, it will work, but it's external, so we can't call it from inside the contract. But let's try and make it internal. Okay, so now let's deploy, and we don't have it here anymore. But now let's make another contract. So let's call this my or another contract. Okay, so here let's make a function called I don't know, add. Okay, so or no, let's call it add vote. But here let's extend my contract. Let's say is my contract. Okay, so basically this is like a child class of my contract. Okay, it's a derived contract from my contract. Okay, so here let's have this method called another method. Okay, so here let's first try and call add vote. Okay, let's see, deploy, and we have 0 votes. Now we have 3 votes because remember this is calling add vote 3. Okay, and let's call another method. Everything is okay, and now we have 6. Okay, because this is calling add vote, which is calling add vote 3, but this is public, remember. Now let's try and call add vote 3 directly. Okay, directly. Let's deploy, and everything is working fine because this is internal and this is an instance of my contract. Okay, remember, it's derived from my contract. But now what happened if we try to call add vote 2? Okay, we get an error because it's not seeing this function because it's private. But let's go back here at vote 3, okay, which is internal. If we remove these, we'll get an error as well because now we can't use this internal because this is not an instance of my contract anymore. Okay, so I hope this clarifies those 4 modifiers. Okay, so now let's see what other types we have in Solidity. We've seen int, so we have int. Okay, we have uint, which comes from unsigned integer. That means we can have -5. Okay, we can only have 5. Okay, my bad. Okay, so we can have 5 here. Okay, we have bytes, okay, which can store bytes. Let me see, we have addresses, okay, which can store an address, uh, basically an account on the blockchain network, okay. You can use this to identify someone or to send some Ethereum to it, and I don't know, a lot of logic around this. We can define a struct, okay, so a custom struct, I don't know, my struct, and here we can have an int, I don't know, ID, and maybe an address, and so on. And we have a mapping, okay, which is basically just an array with a key and a value. So you can have here, I don't know, we can have int, okay, so that means you have something like I don't know, this, okay. So you can have another mapping, I don't know, maybe with an int and my struct, okay. And I don't know, you basically can have any type here and any type here. And we also have enumerations, okay. You can have I don't know, okay, and we can have this, and I don't know. Okay, so I think those are the main types. If I forget something, my bad. You can go to the documentation and read a lot more about this. Okay, so now let's go and move to a more recent uh, Solidity version. Okay, so let's see this one, for example. Okay, so now I want to talk about two function modifiers, to be more specific, view and pure. So let's take a quick example for those. Let's take two variables, okay, and let's take a function that will add those two numbers. So first we need to say returns, and we return an uint, okay. This way we tell Solidity what are we returning, okay. So let's just say return a plus b, okay. So I don't know, let's see what the problem is here. Okay, yeah, now we have to explicitly say public, okay. And now we get a warning already. So how let's first go and see if it's working, okay. So let's click add, and if we go here we see we got 15, okay. So 10 plus 5, 15, it's working. But we can use view here as it's saying in the warning, okay. Why? Because view it's used when you don't change state variables, basically. So we can say public view, okay, and we save, no more warnings. We can go ahead and deploy this and test it again. and as we can see we got 15 again. Okay, so what about pure? So pure, it's used when you don't read variables, you don't even read them. Okay, so I don't know, maybe but let's go ahead and say pure. Okay, so we get an error. Okay, it's basically say that we read variables and to make this view. So I don't know what example I can give you here, but for example, if I say 5 plus 9, I don't know. Okay, so it's working because I don't even read or write uh, variables. So I can go ahead and deploy this and click add, and if I go here we have 14. Okay, so basically pure is when you don't read or write to state variables.